Welcome to Narayana Online live digital classes. In today's session, let us discuss problems on work, power and energy. Moving on to our first slide. In this, it is given in which of the following the work done by the mentioned force is negative, right? So now here, if you could consider, the first option is given as work done by tension in the cable when lift is ascending up. Let us now try to consider our first option here. When lift is ascending up, let us say that this is the lift. Lift is ascending up. That means its displacement is in the upward direction and tension would be acting in the upward direction. It is the tensional force. So we all pretty well know that work done is equals to F bar dot S bar. As per our problem, it is Ts cos 0, right? So here we say that our work done is positive. Okay. Second case, work done by the gravitational force when a body slides down the inclined plane. So, when a body is sliding down the inclined plane, the component of weight mg cos theta acts down the inclined plane and the displacement of the body also would be down the inclined plane. Hence, you say that your work done is equals to Fs cos 0 over here, where theta is the angle between displacement and component of weight along the inclined plane. So, this is also considered to be positive over here. This is regards to our second option. Coming to our third option over here, when we try to consider the work done by applied force to maintain uniform motion of a block. So, when you try to consider the uniform motion over here, work done would be 0 over here, right? Coming to the fourth one over here, uniform motion means acceleration would be equal to 0 over here. If it is moving with uniform velocity, I mean to say, if it is moving with uniform acceleration, if you could consider here, nothing is specified. If it is moving with uniform acceleration, then you would try to say that it is positive. Okay, so either way, uniform velocity, if it is moving with acceleration goes 0, work done would be 0. If it is moving with uniform acceleration, then we say that the work done is positive over here. Coming to the fourth case, work done by gravitational force when a body is thrown up. So when a body is thrown up, the gravitational force would be acting in the downward direction. Displacement of the body would be in the upward direction. So work done is equals to Fs cos 180. Fs cos 180. It is minus F times S is what is the work done. Minus F times S is the work done. And hence our fourth option is correct. Right? Moving on to our next slide, a man pushes a wall and fails to displace it. He does. See now over here, every one of us, we need to remember that work done. How do you define work? If applied force causes, or if force causes displacement in the body, then work is said to be done on the body. See now here, you need to understand that if the internal force causes displacement in the body, then work is said to be done by the body. But finally, displacement should be there on the body. If displacement is produced in the body, then work is said to be done. Either by the system or by the body or on the body over here. If it is not causing any displacement, fails to displace, then work done is said to be 0. That is no work at all over here, right? When there is no displacement, no work done. Moving on to our next slide. In the next slide, it is given that a man is rowing a boat upstream, and in spite of that, the boat is found to be not moving with respect to the bank. The boat is not found to move with respect to the bank. The work done by the man is, see now over here, when there is no displacement, work done is considered to be 0. No displacement implies work done is zero, right? Moving on to our next case. A ball is thrown vertically upwards from ground. Work done by air resistance during its time of flight. So when we try to consider the time of flight, a body is thrown vertically upwards over here. Body moves vertically upwards and then comes. So this is the upward motion we would try to consider. Upward motion. And from here to here it is the downward motion over here. Downward motion. So now here we would try to consider that body is moving in the upward direction. When body is moving in the upward direction over here, upward motion, air resistance we need to consider. Air resistance would be opposing it. Air resistance would be acting in opposite direction over here. But the displacement of the body is in the upward direction. Displacement of the body is in the upward direction. So air resistance and displacement are opposite to each other. Air resistance is a force that we would try to consider, and this is the displacement are opposite to each other. So work done during its upward motion, is equals to Fs cos 180. So it is minus F times S. It is the work done in the upward motion over here. Work done in the upward motion. Right. Next, in the second case, downward motion when we are trying to consider. Body is coming in the downward direction over here. This is the motion of the body. Motion of the body. Motion of the body. Right. Body is coming in the downward direction over here. Hence, air resistance would be acting in upward direction. Air resistance would be acting in upward direction, and displacement would be opposite to this. So again, work done during downward motion when you are trying to consider downward motion, it is Fs cos 180 again. So it is minus Fs. So in both the cases we are getting it to be negative over here. So it is negative during ascent as well negative during descent. Okay. Moving on to our next slide. If F bar equals to 2i cap plus 3j cap plus 4k cap acts on a body and displaces it by 3i cap plus 2j cap plus 5k cap, then the work done by the force is, work done is equals to F bar dot S bar. So which is now equals to 2i cap plus 3j cap plus 4k cap dot S bar is equals to 3i cap plus 2j cap plus 5k cap. Okay, so I cap dot I cap is equals to 1, 3 2s are 6, I cap dot j cap is 0, I cap dot k cap is 0. So j cap dot I cap is again equals to 0, j cap dot j cap is equals to 6. So it is again 6 plus k cap dot k cap is equals to 1, 5 4s are 20. So now the work done is equals to 32 joules. 32 joules. Okay, so this is the work done here, right? Now, moving on to our next slide. In the next slide, it is given that a man weighing 80 kg climbs a staircase carrying a 20 kg load. Okay, the staircase has 40 steps, each of height 25 centimeters. If it takes 20 seconds to climb, the work done is. So now, work done is equals to F bar dot S bar, right? So the man would be trying to apply force onto himself internally so that he is climbing up the staircase. When you happen to consider, when you could consider the staircase over here, when you could consider the staircase, okay, so man would be exerting a force against the gravitational force in the upward direction. Man would be exerting a force onto himself against the gravitational force, and his displacement would also be along the same direction over here, right? So now here F is equals to, he will have to apply a minimum force that is equal to the weight that is acting on the man. So it is mg into S. Okay, mass over here is 80 and he is carrying a load of 20 kgs. Okay, G is equals to, depending upon the options, since options are given in terms of 98, 490 over here or 784, we would try to consider our G to be equals to 9.8. He is climbing 40 steps, each of height 25 centimeters. 40 into 25 into 10 power minus 2. 10 power minus 2. So it is 80 plus 20 is 100 into 9.8 into 25 force is 100, 10 power 2 into 10 into 10 power minus 2. 10 power minus 2, 10 power minus 2 gets cancelled off over here. So now here if you are trying to consider, it is 9.8 into 10 power 3. 9.8 into 10 power 3. 9.8 into 10 power 3, which is now equals to 98 into 10 power 2. So it is 9800 joules. 9800 joules is the work done. 9800 joules is the work done, which is matching with our first option here, right? Now moving on to our next slide. In this, it is given that a force F bar equals to 6I cap minus 8J cap acts on a particle and displace it over 4 meters along x-axis and 6 meters along y-axis. The work done during the total displacement is. So, the displacement of the body, writing it in vector form, if you could see, it is 4 meters along x direction, 4I cap and 6 meters along y direction over here. This is the displacement. And F bar is equals to 6I cap minus 8J cap. So we say that our work done is the dot product between force and displacement. So force is equals to 6I cap minus 8J cap dot 4I cap plus 6J cap. 4I cap plus 6J cap. So it is 4 6s are 24 minus 6 8s are 48. So it is minus 24 joules is the work done, which is matching with our third option here, right? Moving on to our next slide. In the next slide, it is given that a lawn roller is pulled along a horizontal surface through a distance of 20 meters by the rope with a force of 200 Newton. If the rope makes an angle of 60 degrees with the vertical while pulling, the amount of work done by the pulling force. Let us assume that this is the lawn roller. In the cricket pitches, if you could observe, you have a roller on the pitch. So that is the lawn roller, we would try to say. It is pulled with a force of F, which makes an angle of theta with the vertical. Hence, it makes an angle of 90 minus theta with the horizontal over here. So now the force along the horizontal direction is F into cos of 90 minus theta, we would be saying, which is equals to F sine of theta, F sine theta over here, which is equals to F sine theta, right? So now you are asked to calculate as what is the work done by the pulling force. Okay, so the lawn roller would be moving along the horizontal direction over here. So work done would be equals to the force that is acting along the horizontal direction. I would try to say it is Fx dot S bar, the Fx bar dot S bar. So it is Fx into S cos 0. The force is along this direction and the displacement would also be along the same direction over here. Fx is equals to F sine theta into S. The force applied is given to be 200 Newton. 200 Newton into sine 30 and the displacement is 20 here, right? So it is 2 2s are 4. So 4000 into root 3 by 2. 2 ones and 2 2000s over here. So which is equals to 2000 root 3 joules. 2000 root 3 joules is the work done. 2000 root 3 joules is the work done, which is matching with our third option, right? Moving on to our next question. The force acting on an object varies with the distance traveled by object as shown in figure. The work done by the force in moving the object from x equals to 0 to x equals to 14. So here we say that work done is equals to area under force and displacement curve. Area under force and displacement curve. So this is a trapezium over here. Maybe you can split up this into OA, A dash here, this is B, B dash here, and this is C over here. So which is just nothing but area under OA BC. This can now be written as area under OA dash plus area under B dash A dash plus area under B dash C. So now if you could consider OAA dash, it is triangular in shape, half base into height. Base is equals to 6 into height is equals to 4 plus this A dash B dash is 10 minus 6, that is length, into breadth is equals to 4, plus half, base over here is 14 minus 4, 14 minus 10, that is B dash C, into height is equals to 4, right? It is now 2 1s and 2 3s here, right? It is 2 1s and 2 2s here, right? Now here it is 12 plus, this is 10 minus 6 is 4, 4 4s are 16, plus this is 4 into 2 is 8 over here. So now here, if you could consider 12 plus 8 is 20, 20 plus 16 is 36. So the work done would be equals to 36 joules. Hope everyone it is clear to you, right? Moving on to our next slide. In this it is given that a particle of mass m is projected at an angle theta with the horizontal over here, right, with an initial velocity u. The work done by gravity during the time it reaches the highest point. So when it reaches the highest point, maybe when you consider a projectile, definitely it would be reaching like this over here. When it reaches the maximum height, you are asked to calculate the work done by gravity. So work done by gravity over here we are now trying to consider, it is equals to the gravitational force dot the displacement over here. The gravitational force would always act in the downward direction, vertically downward direction, mg minus j cap, and the displacement of the body is u square sine square alpha by 2g j cap. Displacement is in the upward direction. So it is mg into u square sine square alpha by 2ge. I take this negative sign outside into j cap dot j cap, and you know that pretty well j cap dot j cap is equals to 1. So it is u square sine square alpha by 2g. It is the work done by gravity. It is the work done by the gravity when the body reaches the highest point, right? In this problem, maybe in the next problem, if you could consider, it is given that two spheres whose radii are in the ratio 1:2 are moving with velocities in the ratio 3:4. If their densities are in the ratio 3:2, then the ratio of their kinetic energies. So kinetic energy, as every one of you are highly aware, it is half m1 v1 square by half m2 v2 square. So these two would now get cancelled. Now mass can be written as volume times density. This is volume, this v is volume and this v is velocity. Volume times density into v1 square by volume times density into v2 square. Now volume can be written as, here the bodies are spherical in shape, 4/3 pi r cube, 4/3 pi r1 cube, rho 1 into v1 square by 4/3 pi r2 cube into rho 2 into v2 square. These two would now get cancelled off over here. Now if we could consider the ratio of their kinetic energies are, r1 cube by r2 cube. Radii are in the ratio 1:2. So it is now 1/8. Okay. And velocities are in the ratio 3:4. That means it is 3 square is 9 by 16. And rho 1 by rho 2, densities are in the ratio 3 is to 2. So it is 27 upon 8 2s are 16, 16, 16 is 256. It is 256. It is the ratio of the kinetic energies, right? Moving on to our next slide. In this slide it is given a large slab of mass 5 kg lies on a smooth horizontal surface with a block of mass 4 kg lying on the top of it. The coefficient of friction between the block and the slab is 0.25. If the block is pulled horizontally with a force of F equals to 6 Newton, then the work done by the force of friction on the slab between the instants t equals to 2 seconds to t equals to 3 seconds is dash. So a force of 6 Newton is applied onto it. So now let us try to consider the maximum static friction or the limiting friction between the blocks, which is mu times n. So now mu is equals to 1 upon 4 into 4 into 10, which is now 4 and 4 gets cancelled, which is equals to 10 Newton, which is equals to 10 Newton here, right? Now, let us now try to calculate as what is since the maximum frictional force, here we would try to say that the limiting friction is greater than that of the applied force over here. The applied force over here, the frictional force is equals to 6 Newton as the static frictional force is a self-adjusting force. Now here, let us now try to consider the common acceleration with which both the blocks move. Now since the frictional force is, the maximum frictional force is greater when compared to the applied force, both the blocks they move together with common acceleration. So that is just nothing but the net force acting on the system by m1 plus m2. So that is now equals to, over here that would be equals to 6 by 9, which is equals to 2 upon 3 meter per second square. Here every one of you need to understand that this frictional force acting on 4 kg block would be acting in this direction, and frictional force on the 5 kg block would be acting in this direction. When we would consider the net force, these two forces they get cancelled off. It is the 6 Newton we have been considering. So now distance covered by the body during 2 seconds is equals to half. Acceleration is 2 upon 3 into 2 square. So this 2 and this 2 gets cancelled, which is 4 upon 3 meters, right? So S3 is now equals to half 2 upon 3 into 3 square. So this 3 and this 3 gets cancelled, 2 and 2 gets cancelled, which is equals to 3 meters over here. So now here we would try to consider the displacement as S3 minus S2. So which is now equals to 3 minus 4 upon 3. So it is 9 minus 4 is 5 upon 3 over here. So work done by the force of friction on the 5 kg block over here is now F bar dot S bar over here, which is M into A into S. Mass over here is 5K, mass over here is equals to 5 kgs over here into acceleration over here is equals to 2 upon 3 into the displacement is equals to 5 upon 3. So it is 25 to 50 by 9 here, 50 by 9. Okay, so this is what is the work done. 50 by 9 joules is the what is the work done. So now when we are trying to consider 50 by 9 upon simplification, it is 5.55 joules. Okay, right, which is matching with our second option. Moving on to our next slide. A block of mass m is suspended by a light thread from an elevator. The elevator is accelerating upward with uniform acceleration A. Work done during t seconds by the tension in this thread. So tension would be acting vertically upwards over here, okay, and the displacement would also be along the same direction. So work done by the tension in the string is now equals to T bar dot S bar. So it is Ts cos 0 here. So when the elevator is accelerating upwards, tension is m into g plus a, and distance is equals to half at square here. So considering that, if you could say it is m by 2 into g plus a into at square. This is what is the work done by the tension. This is what is the work done by tension here. Right? So which is matching with our first option. Right? Moving on to the other slide, it is given that if 250 joules of work is done in sliding a 5 kg block up an inclined plane of height 4 meters, work done against friction is. Now over here we need to understand that work done against the friction is done by the applied force. Work is done by applied force. Work is done by the applied force, and work is done by the gravitational force. Work is done by the gravitational force. Right. So now this is m into the acceleration due to gravity acts in the downward direction, and with our given data it is equals to 250 joules of work is done by the applied force. So it is 250 joules of work is done by the external force. It is mg into h over here, the work done. Okay, so it is 250 minus mass of the block is 5, g is 10 into its height is 4 over here. So it is now equals to 50 joules is the answer here, which is matching with our first option. Moving on to our next slide, it is given that a particle of mass 2 kg along a straight line with velocity v equals to a into alpha root x, where maybe you can say alpha or a is a constant over here. Okay, you say it is alpha. The work done by the net force during the displacement of the particle from x equals to 0 to x equals to 4 meters over here. Right. So now here we would try to say that work done would be equals to change in kinetic energy. This is according to work energy theorem. Work energy theorem. Work energy theorem. Work done by a constant force is equals to change in its kinetic energy. So it is half mv square minus half mu square. Right. So which is half m into v square over here is alpha root x whole square minus half, this is final, I mean to say it is half m alpha root x, this is initial whole square. So that is just nothing but half m into alpha square x final minus half m into alpha square into x initial. Now here if you could consider, this is now equals to half m alpha square into x final is equals to 4 meters minus half m alpha square into x initial is 0. So which is now equals to 2m alpha square. Okay, mass of the block is equals to 2 kgs, so it is 2 into 2 into alpha square. So which is equals to 4 alpha square, which is matching with our third option, right? Hope every one of you, it is all clear to you, and thank you all.